Okay, parents, I'm going to kind of talk through and show you what it is that we're going to do this unit and give a brief overview with some examples and to explain where we're going. So hopefully that if you get into a conversation with your student, we will be able to talk through that. So when we take a look at what we have going on, we have four different ways to describe motion. We have words, we have something called a system schema, we have a force diagram, and we have a force additional diagram. The system schema are all of those things that are in play. So in this case here, that we have a bird, okay, and it's sitting on a perch. And we have the earth, which is going to be pulling it down. And then our system schema, we circle our things, our objects. And once again, these are objects, not forces. So the earth acts on the bird acts on the earth, the bird acts on the perch acts on the bird. So this shows us that we have two forces. Our force diagram, we make our object be a circle, and we show our forces by vectors. Vectors have both direction and magnitude. And the upward force on this case is the perch pushing the bird up. And that may seem a little bit odd to you, but we call that a normal force or force normal. And we do object-agent notation, not agent-object notation. Our object is the bird, and it's being pushed on by the perch. And we have a force going down, and that is the force of gravity, and that is on the bird. And by doing object first, as long as all of these are birds, we should be good. And that force of gravity is called by the earth. And the force addition is going to be kind of the same thing. And we put our little tick marks there to show that they are congruent, and we use the Greek symbol sigma to say it means sum of those forces equals 0. And anytime our forces are 0, the object is not going to be accelerating. So let's choose one. Let's do this one here. This is one that we did with as a class. So we have a baseball player who slides into the base. So our system schema, we have our player, we have our earth, okay, we have our ground, and in this case here, the earth is going to be a downward force of gravity, the ground is going to be an upward force of normal, and we have to have something that is stopping. And if you want to say the base is stopping or the sand is stopping, I'm just going to use base. So we have the earth acting on the player. And once again, our player is kind of our object. So the earth acts on the player acts on the earth. The player acts on the ground acts on the player. The base acts on the player acts on the base. And in this case here, we have our upward force, which is our force normal. It's not always going to be a normal force, acting on the player, comma, by the ground. And we have our downward force, which is our force of gravity, on the player, comma, by the earth. And we have a force, the slider is going that way, the force of friction, or the base, is pushing in an opposite direction. And we're going to call that the force of friction on the player, comma, by the base, we called it. And you could call it whatever you want. So we have our forces. Our vertical forces are equal. So the sum of those forces equals 0. But now we have an unbalanced horizontal force, and those are not equal. So anytime our forces are not equal, we have acceleration or a change in velocity. And that is going to then, an object is either going to slow down or speed up. Okay, so from there, we are going to go into a formula that is weight is equal to the gravitational force times the mass. And we're going to do an activity or a lab on that. And with that, really close to that, is force is equal to mass times acceleration, where our masses are the same and the acceleration, this is due to gravity, this would be due to some force like an engine or something like that. So we will spend some time calculating problems using these two. And then we'll be taking a look at adding some forces. So it's kind of like if you are pushing a wagon and you run into another wagon, that how do we add those forces up? And that's kind of the unit in a nutshell. And let me know if you have any questions. I just kind of thought that it would maybe help if you knew what we were doing. Otherwise, have a Merry Monday. Thanks.